Okay, there we go.
You know what? I'm doing it. Don't worry.
Oh, there we go.
Perfect.
We are now recording.
Okay.
Over to you, Joe.
Yeah. So today I'm going to talk a little bit about performance and N+1 queries in GraphQL. So recently I've been working on branch rules. So we're moving branch rules to the configuration for pushing the branches, merging the branches and stuff like this to a separate page, so it's easier for people to view and configure. And that's included me creating a whole new type within the GraphQL endpoint. So first, I'm just going to talk a bit about how GraphQL actually works. So the graph schema is made up of multiple types, and a type essentially defines an object that can be returned by the API. And within the type, you specify various things like the name of the type. If you look at this one here, it's project. Some authorization stuff, we'll skip over this for now, and then fields. So each field has its own type. Base fields would be like string, integer, boolean, and then we can have other types like custom types that we've defined. So for example, here we have branch rules, which is the type on here is a project's branch rule type. So this is one that I've created. This can lead to, so this is the branch rule type, which also has its own fields. This can lead to interesting queries because types can actually loop back to their parent. So for example, we could have the project type could have branch rules, and then within the branch rules, we could have a field that links back to the project. And this would allow the client to create these looping queries that essentially are querying for the same data all the way down. So this, these queries can get really, really big, and we have two mechanisms to kind of stifle this. We have depth, which configures like how deep somebody can query down, and then we also have maximum query complexity. So the complexity specifies, how much of a performance hit each of these fields is going to cause to our request. So by default, each of our fields, I think by default, each of them has a complexity of 1. And then our schema defines the maximum complexity for the whole query. So if you're not logged in, the default is 200, authenticated is 250, for admins it's 300. So this would mean that for a non-logged in user, they can query 200 fields that all have a complexity of 1. However, we can also specify higher complexities. So for example, if we're unable to preload some data, or maybe the SQL for that field just isn't very performant, we can add a complexity configuration to the field itself. So for example, this descendants groups returns a collection of groups, group type, and I'm not exactly sure why the complexity here is 5, but this is just an example. So this field is, we've marked it with complexity 5, which means that if somebody tries to query this field, it bumps up, the maximum allowed complexity for the overall query. That will allow us to, prevent, essentially define like how much performance we want to allow on our, or how much our infrastructure can deliver. So if we want to scale down our servers or databases or whatever, we can lower the maximum complexity, and that will prevent people from overloading the servers. So that's the first way we can deal with some of these fields that aren't super performant. And then the second thing that I want to discuss is fetching data. So often when we're fetching data, we can introduce N+1 queries. So to resolve these N+1 queries, we can use two different mechanisms. So we have batching and look ahead. So the batch loader allows us to, so if I just show you this class, so we've got this user resolver here. And so maybe first I should discuss what a resolver is. So each of these fields, let's go back to here. So this branch rules field, by default, what's going to happen is it's going to call in here, like a lot of serializers, we use the term object. So object is the object that's passed into this type, and we would call branch rules on that object. But sometimes we might want to, customize where the branch rules are being fetched from, or we might want to pass in, some arguments or something. So in that case, we can create a resolver, which is actually what's defined for this branch rules field. And then let's go back to the batch loaders. So if we look at this resolver, we can see that there are two arguments that can be specified here, ID and username. And then within the resolve method, which is the GraphQL Ruby method that is called, we first do some authorization, and then we check if the ID is passed, and we just look it up from the schema, or if the username is passed, we do some batch loading. So this allows us to create a list of users. So we're going to pass an individual username to this, but we might be trying to load 10 users with 10 different usernames. So rather than querying for them one by one, we can create a batch of usernames, and then once we have all of those usernames within this batch loader, we can then load those and assign them to the username value. So there's a lot of magic happening behind the scenes here, but essentially what it's doing is creating a key value list that's going to look up. We're going to load all of the users in a single query, and then when we actually want to find the user for this particular type, we're just going to fetch that directly from this list of users inside the loader. I haven't actually used this myself, so I don't understand exactly how the mechanisms within this work, but it's something you should be aware of that's possible, and in some situations it might be useful. However, the tool that I've currently been using to preload some data, just notice there's a chat here. What are we looking at? Okay, that's odd. Okay, so look aheads. A look ahead is a representation of the query that's been supplied. So when a user queries the GraphQL endpoint, we can see what they've queried for before we actually resolve that data. So that allows us to build a list of associations that need to be preloaded without preloading data that doesn't need to be preloaded. So if I so this is the branch rules resolver. So this is originally what it looked like before we added the look ahead. Ignore this look, include look ahead here is actually, this shouldn't be in there. I just reverted and took a screenshot, but this module should not be included. So this resolve method was just aliasing essentially, where we're fetching branch rules from. It's actually the protected branches model at the moment. In the future that'll change, but for now it's that. So if we want to add the look ahead module so we can inspect what the user has queried for, we can do that by including this looks ahead module. So this looks ahead module configures, some GraphQL DSL stuff. So it's going to tell the graph that we want to request a look ahead, and then it's going to assign the look ahead to this attribute accessor, and then it's going to call resolve with look ahead. So now we can convert our branch rules resolver to, instead of the resolve method, we're going to use resolves with look ahead, and we're going to use this apply look ahead method to the scope that we want to resolve. So if we take a look at this apply look ahead method and figure out what's going on, first it's going to try to find all of the preloads, and then it's going to preload that data. So where's it going to look for the preloads? So the first place is this unconditional includes method. So if we take a look at what that's actually doing, by default, this is just going to return an empty array. However, if we override this in our resolver class, we can tell the resolver that we always want to preload some of the associations for that model. So for example, here, if we just add unconditional includes, we can say, regardless of what the user has requested, we're always going to preload the approval rules and the users and groups nested within that. And then we can do some conditional stuff. So sometimes we may want to preload based on what the user has requested. So here we can see our preload function method is going to return this hash. So the key here is going to be, we're going to look in the look ahead to see if this key has been requested. So I'm not sure if I put an example in here. I didn't. Maybe I can show you. Maybe it's not worth it. Okay, so what this is actually going to do is it's going to go into, it's going to look at the look ahead, and it's going to say, does this select approval rules? And if it has selected approval rules, it's going to try and preload approval project rules, users, group users. And then it's going to do the same for external status checks. If this has been requested, then we're going to preload the external status checks. So that's quite straightforward. It's quite easy to understand and allows us to preload data very simply without actually interacting with the look ahead ourselves. We also have something that was introduced a month ago or so, which is nested preloads, which essentially behaves exactly the same way as the preload method, except it's going to the look ahead keys are not just the top level, it's also the next level down as well. So for example, if we want to preload, what have I written here? Yeah, so in the preload method, we defined this external status checks. We're going to, if external status checks is being requested, we will preload the external status checks. So if the user has submitted this GraphQL query, we can see external status checks were requested, so that will be loaded. However, nested preloads is going to look 2 levels deep. So if we request branch protection, and within that we've also requested merge access levels, then we're going to preload the user. So in the following query, this would not preload the merge access level user, even though we've requested the merge access levels. So you can see here we've got projects, branch rules. Within the branch rules resolver, we're checking if branch protection has been requested, and then if merge access levels have been protected, then we'll load the user. However, wait, sorry, that's slightly wrong. This example is actually slightly wrong, but I think hopefully you understand this. So in this first example, we've requested the merge access levels, but we haven't requested the user from that merge access level. In the second example here, we have requested the user and their name. So our conditional logic would check that, and essentially it would only load the user for this second one, as the first didn't do that. So those are built into the looks ahead module, and they're quite self-explanatory and easy to use. And then we have another situation where you might want to do some more complex checks, where these preload and nested preload methods don't quite fit our needs. So for example, with branch rules are set up quite strangely at the moment because we don't actually have a branch rule model. So when you query a branch rule, there's also a field inside that called branch protection, which is actually the branch rule and the branch protection are currently the same object, which means we need to use this nested preloads. So first we want to check if branch protection's been requested. even though it's the same object. And then we want to check if the merge access levels are requested within that node. And once we do that, we also then want to check if the group or the user has been requested. So we can see here in our nested preloads, we're supplying the branch protection key, and then within that, the merge access levels key. Deeper than that, the current looks ahead module doesn't allow us to go deeper than that. So what I've actually done here is manually built the list of preloads. So I'm going to check if see on line 24, we've got access level preloads 4, and we're going to find the access levels look ahead. So that's at the bottom here. So we've got the look ahead at the root of the query. We're going to check if it selects branch protections, and then we're going to select the access level. This could be either merge, push, or unprotected access levels. And then we're going to fetch the node selection. So it could either be edges node or just nodes. And that's going to return the look ahead specifically for the access level part of the query. And then we can detect within that look ahead if the group has been selected or the user has been selected, and then we can manually build these preloads. So here we're just loading the SAML provider and the routes and the parent. And for the users, we preload their groups and their projects. So that's a bit more complex and gives us a lot more flexibility, but also means that we need to do a lot more of the work ourselves. So that is the end of my presentation. If anyone's got any questions, fire away.
I don't have any specific questions, but it was very useful for me because I've avoided GraphQL since I joined. So it's been quite nice to actually have it explained, not from a front-end perspective.
GraphQL is a bit of a monster, and I think implementing it in Ruby is definitely even more of a monster.
It's amazing how abstract it gets quickly.
Especially when it's wrapped in a DSL. Like there's so much magic happening underneath. It's really quite hard to figure out what's happening. Patrick, you've got your hand up.
I had a question about the complexity thing. So you said like a complexity of 300 means that we can have 300 query requesting one object, right?
No, so let's for example say we're just requesting the let me see if I can track this into the view.
I wanted to know if those objects can be nested within one query that you have like 300 nested objects,
Yes,
300
you can,
200
nested fields. So the depth, currently the depth of how far you can query is either 15 or 20, but you could, the width of that, the width of each node is currently unlimited. I mean, you reach the complexity limit, right? So you could have, let me see if I can get the graphical interface. Right, can you see this? If I have graphical, can you see?
I see Google Chrome.
Google.
So but can you see graphical?
Yes.
Perfect. Okay, so for example here, like the query is for the project, and that project has multiple fields on there, like for example job. By default each field will be one, so we could have 300 different fields all the way down here.
Okay.
Or you could have like one field like branch rules, and within that have another 299 fields. Does that make sense? Each field each field adds up to the max complexity, but we also have a separate config for how deep the these nested queries can go.
And how width is then 15?
Well, that's depth.
like
So
that.
that's how,
Yeah,
you know,
that,
how nested it could be, right?
yeah. And is there? I know there used to be a problem in GraphQL. I don't know if it has evolved, because the last time I really used GraphQL was with JavaScript. Is there anything to avoid circular complexity, like the same project calling the same user, calling the same project, calling the same user?
Yeah, so this is, you know, this is what I was, so we can actually preload that data and, you know, using this batch loading strategy.
Oh yeah, that's true. Yeah.
Instead of doing the query multiple times, we can just return the same object. However, like the complexity, we can also use the complexity to kind of prevent people from doing those queries.
Yeah. Okay.
Yeah. Sean?
Yeah, yeah, it's my mind is a bit blown, but one thing, because going back to the original premise of this talk, right? Like, it seems I'm wondering how it seems like to me that everything would generate an n+1 practically in GraphQL, unless is the schema all loaded into memory and doesn't need to touch the database. I mean, how do we avoid multiple n+1s, I guess?
Yeah, so I haven't verified this yet, but I have a feeling that quite a few of our endpoints do actually have a lot of n+1s. So something else I forgot to show you was the actual tests. Show you.
Like it seems, because these definitions are stored in eventually in tables, right?
Yeah, so I mean it's a schema, and then based on the query that's, you know, sent, we build a list of queries that we need to fire, and then they just fire and return the data. I'm not exactly sure how it works under the hood, but
no worries. Yep.
There's definitely a lot of room for n+1 queries to happen if you're not careful, and I think it's going to take a lot of effort for us to really keep on top of, you know, making sure that doesn't happen.
I've checked sorry.
Yeah, carry on.
I've checked the implementation of the loaders back in with JavaScript again. It's actually not super complicated. It's just a hash list that they filled up with the parameters that you give them. And if the parameters are the same, they don't recreate or they don't append again the same values. And
yeah, so that's similar to the way it works here. The thing is, you could preload all the data from the root level. So like if we're querying from projects and then inside that the users within the project or whatever, we could, from the root level, we could say, okay, what's been requested and preload everything. But sometimes it might actually be more performant to split those queries up. Like maybe like you know, querying for the project and preloading all users is, you know, terrible. So
it's not a magic solution to put a loader.
Yeah, there's no exactly. Yeah. And it's all manual, like we have to do this manually. There's no like magic implementation that just does it for us. So yeah, okay, so this is n+1 spec. They're actually quite simple to build. However, there are a couple of gotchas, which includes one that I struggled with this week, or last week, which drove me a little bit crazy, which is user tracking. So Devise has some methods to track when the user's logged in, tracks their IP last logged in at, and stuff like that. So I've added some logic. So RSpec has these spies. I'm sure everyone's aware of this stuff, but like allow users to receive blah and return whatever. So I just added a shared context that essentially just turns all of that stuff off. But yeah, the basics for doing an n+1 spec is you set up a control with an active record query recorder. You submit the request once. Some people have been checking GraphQL errors empty. Some people don't. There's a bit, there's a bit of a not so much of a strong consensus on how to do these. I found that it's probably a good idea to add, this method, because sometimes you'll actually get errors back, and then you don't know if you're checking the correct queries essentially. And then you want to create another record so that you would create an n+1 if there's one present. and then submit the query again. And this is actually in the wrong order. That should be below. Yeah, and then submit the query again, and we've got this custom RSpec matcher exceed all query limit, which basically checks if this control up here has more queries, less queries than this one. So it's quite a simple test to configure. But yeah, there's a couple of issues that you have to be aware of. I think like if you do these tests, like you should probably put a pry in here and just actually confirm that the control and the second query, the number of queries that was submitted actually match. Sorry, Igor, you've got a question.
Yeah, just a quick note regarding the test. Yes, sometimes it makes sense to call a single like GraphQL query before even recording the number of queries. Yeah, like a warm up.
Yeah. So recently, I'm not sure how many people saw it, but Jessie, I can't remember her last name, but she mentioned this in Slack that she's created a new. She's trying to create a new guideline essentially. So you should turn off the SQL query cache, and then your query recorder should also skip cached, false. And doing this prevents any of the cached, essentially means you don't need to warm up the cache. So we should be able to, theoretically, we should be able to remove those initial queries if we do it this way. However, it does mean you need to turn off, this user tracking and stuff like that.
Yeah, makes sense.
Any other questions or comments? Okay, well, we're a bit over time. Thanks so much, Joe. This was, I would say, mind-blowing. I thought I knew something about GraphQL, but clearly my knowledge is very shallow, and very interesting. Thank you so much.
Yeah, no problem.
I'll stop the recording.